So now we are going to introduce two methods to find the power of the power function that can fit a set of data. Okay, so here we have here the x-axis is going to be the distance in meters, and the y-axis is going to have the magnetic field in Tesla. These are the values, and when we plot the magnetic field with the distance, we can see this curve, and basically we need to find the power function, or the power of the power function that can fit this curve. So basically this is a power function that we have here, y equal to a constant, x the variable to the power of n. So the requirement here basically is to find how much is n exactly, okay, so that we know the power that can fit this curve. So we can do this, as we said, using two ways. The first way is basically using this concept. If we come here, we have this is a function, okay. If you take the natural logarithm of each side, basically len y equal to len a to the power xn, and from the rule that we know that the multiplications and the natural logarithm, it becomes addition. So the len a x to the power n is equal to len a plus len x to the power n. Then basically the power goes outside, becomes a multiplication factor, and basically the function becomes like this: len y equal to len a plus n len x. So you can see from this function that we have, this is the output, this is a constant, len a is a constant, and n is the power, and len x is a variable. So we can see it's a linear function, okay, that has a variable of len x, and the slope of this function, as we know, it is n, which basically it shows the power of the function that's going to fit. So we do the same as here. Basically, we are going to have here, there's going to be, we are going to get the len of the y-axis, which basically, let's say, len y, it's going to be this function, so it is equal to len, this one, of this number. Let's close it. Then basically we need to have this all the way down. Then let's do the same for this one. So we need to see len sorry, not this one. Len of x, then this one is equal to len of this value. Then we go all the way down. So we can see these are the two curves. We can plot them if we want. So let's plot them just for the sake to know what the shape of this one. I'm going to say that this is going to be the y. Let's go insert curve. This is the one, and basically let's change the x-axis. There's this one. Then basically this becomes x-axis. So this becomes the line that we need the slope of it, basically. To do this, we will use logistic regression, and to get this, basically we have to make sure that we have, in data tab, we can have data analysis, okay? If you don't have data analysis, you need to do the following. Go to files, then go to options, and from options, you need to get adds n. Then basically you search for it. Where is it? So we need this one, analysis tool pack. If you see it, you will see it usually here in the inactive application. So what you need to do is basically press go, then select it, analysis tool pack. Then you say OK. When you press this, you will find it here under the tab data. So we have it now. So let's select data analysis. And from data analysis, we are going to search for logistic regression or regression. So we have it here. We put this one. So we need to find the y range, which is this one. Then we get the x range, sorry, this one. Then we press OK. Then you have here a new sheet that's reduced, and basically you can see these are the coefficients. The coefficient of the x variable is minus 2.9, and this is the intercept. So basically this is the slope that we have, which n is equal to minus 3. Okay, so this is the first way to find the power function that could fit this curve. The other, or the second method, it is going to be using solver. Okay, using solver, which basically we are going to do it as the following. So first, to add solver, we will do the same. Go to File, Options, then Add Ends. Then you find solver. Usually you will find it here in inactive. You don't find it under the Data tab. So you find it here. So basically, you click on it, go to Go, then you check mark to include it in the Excel sheet, then basically OK, so you can see it here. So now what we are going to do is that solver, it's basically we are creating a function. So now we will talk about using solver in order to solve this problem and to find the n, or the power of this function that would fit this one. So the idea here that y right now is going to represent the function that is going to fit the magnetic field. So we can say that we have a model. Let's say this model, we call it model. Okay, and basically this model, let's color this one. So let's say this model basically has two constants. We need to know what is the number a, how much the value of this one, and how much is n, the value n. So let's call that this is a, and this is going to be n. So from here, let's say that basically solver, what it's going to do is going to substitute the variable a and n with different values until this function, which is the model here, is going to perfectly, or like as much as it can, to fit this curve. Okay, so we can say that the first value for a might be 1, this value for n might be 1 as well. Let's initiate initialization, and let's say the model is equal to ax to the power n. So, but before this, let's basically define these variables. So we can say that we have the variable distance, the variable magnetic field, and the model itself. So we need to go to formula and basically create from selection. So we need to have these variables, and top row means that the top row represents the name of the variable. So we have the variable distance, the variable magnetic field, the variable model. Okay, then let's select this one. Then now we have these two variables, a and n, the constant here and the power. So let's select these, and we also select create from selection. So from here, we select the left column, which means the left column has the variable name, a, n. So from here, we can say that the model itself is equal to a, which is this one, multiplied by x, and the x itself, it is what? It's the distance. So it's the distance here. Then basically to the power of n. And n basically this one, this variable, which represents this n. Then we press enter. Then basically we have the model here becomes these values, which is represented by y equal to a x to the power n. So these are the values. So in order to use the solver to find the best a value and n value, we need to define a cost function. Okay, a cost function. This cost function basically shows the difference, how much the model is different than the magnetic field, which means that we need the cost function to be as low as possible, the minimal value. You get the difference between these two values, the model value and the actual value, okay, and basically get the summation of the squares of these differences. And we need to have this value to be minimal. So let's say this one is equal to sum product. So the summation of the product value of two values. The first value is going to be the difference, magnetic field, minus the model value. So basically, the first section we have magnetic field minus the model, the difference between these two, and we need this difference to be minimal. Okay? And basically sum product, we are going to get the square of this, so we'll use sum product for the same difference. And basically we are going to press enter. So we get the cost function, in this case is 0.2839. Okay? The cost function is equal to basically cost function is equal to the y, the model, -2 the t square to the power 2, basically, and the summation for all values. And if this one is 0, that means there is no difference between the model created and the magnetic field. So this is the cost function, and we need to make it minimum. So now let's go to data and select solver. And basically here we need to have a minimum function, or to get the minimum value of the cost function. So here we select or put the cost function itself, which is the value that we need to bring the minimum of it. And from here we need to change some variables, and the variables that we are going to change basically is the value of a and the value of n. So we select both of these. These are the variables that I am going to change in order to find the cost function and to make the cost functions minimum. Then in this case we would like to, the best way to get the minimum value, we go to options and we select GRG nonlinear, and we make it like smaller value, and we use the derivatives to be central, and we press OK. Then from here we are going to solve, and basically solver is going to substitute a and n with different values until we have the cost function to be minimum. And basically the minimum is going to happen when we have the best fit for this curve. So let's see. So right now, as you can see, it's finished and give us a cost function of 2.3 multiplied 10 to the power minus 8. And basically we can see the a value is equal to 0.001, and the n, or the power, becomes almost 3. So we can see that the power of the function is equal to 3 that we can fit here. So the power that we have is basically 3 using solver method. I hope you like this video and you knew about the two ways basically using the natural logarithm of the function itself and get the slope using logistic regression or using solver, and basically substituting these two variables with many values while trying to get the minimum value for the cost function that we have here. I hope this was beneficial. If you like it, please press the like button and subscribe to the channel and wait for my next video. Thank you so much.